Hey everybody, let's do a little factoring. Starting with number 34 on the review. The factoring is a way of solving quadratic equations. So by quadratic, I just mean there's something that's being squared in the equation. And basically, it all comes from, like with inverse operations, if you have 2n equals 4, you just divide by 2, and you can solve for n. If you have n squared equals 4, you can take a square root and solve for n. But if you have both an n squared and an n, like we do here, n squared and an n, you can't just take the square root of both sides, for example. You need a new method. Like on this one, number 34, if we square root both sides, we end up with n equals the square root of negative 16n minus 64, which is a little difficult to deal with. So how do we do this? Well, first thing you want to do with a quadratic is you want to move everything to the other side or to the same side. So if I add 16n and 64, then the right side is now 0. And the left side is n squared plus 16n plus 64. There is the quadratic formula is a way that we could solve this. A is 1, B is 16, C is 64. So you do the old negative B plus or minus the square root of. But these all solve by factoring. So what that means is that we want to basically take this expression and split it into two expressions that are multiplied by each other. And if we want to know when they multiply to be 0, then if either factor, if n creates some or makes either factor be equal to 0, then the whole thing becomes 0, and those are our solutions. So every quadratic you can do this, you can turn it into something where 0 is on one side. That way you can use all these methods. So let's do, how do we factor? We do a times c. A is 1, so it doesn't change anything about c. C is the number that we need factors of. Numbers that multiply to be 64, they need to add up to 16. Last time I checked, 8 times 8 was 64, and 8 plus 8 is 16. So this becomes n plus 8 times n plus 8 equals 0. You could rewrite that as n plus 8 squared, but this is a factored form of the original. If you multiply it out, you would get the original. And we set each of these equal to 0, n plus 8 is equal to 0, and we solve. So if n plus 8 is being multiplied by something. So if n plus 8 equals 0, then we're going to multiply, and whatever we multiply it by will be 0 as well, or will become 0. So what value of n would make n plus 8 be 0? To get n equals negative 8. And what that means is if I plug in a negative 8 for these n's, negative 8 plus 8 is 0. So 0 equals 0. So that's my solution. Both factors are the same. So this is called multiplicity, but both of our answers are negative 8. There's only one unique answer. Let's jump to 37. Same process, but this one's already set equal to 0 for us. So we just do A times C. We get negative 24. That's the number we want factors of, and they have to add up to negative 5. If you wanted to do this on your calculator, you could hit y equals. Let's just do that. You hit y equals, and then you can type in the number that you want factored, negative 24, divided by x, second graph, and now every row that contains, mine are all going up by 0.1, but every row contains factors of negative 24. You just have to find the ones that add up to negative 5. In this case, it would be 3 and negative 8. 3, negative 8. And so we have x plus 3 and x minus 8 equals 0. I forgot last time to say this, but you have to divide both of these by a to finish the factoring process. However, a is just 1, so it's not going to change anything about my factors. This is the factored form. So realize now that it's asking us to do 2 things. It's asking us to factor. It's also asking us to solve. So we're using factoring as a method of solving. So if x plus 3 equals 0, it doesn't matter what x minus 8 is. X minus 8 is going to be multiplied by 0. Therefore, it's going to be 0. Everything's going to be 0. So x equals -3 is a solution. If x minus 8 equals 0, doesn't matter what x plus 3 is. And that happens when x equals 8. So those are my 2 solutions. I'm going to jump down to number 40 now. Here we have another quadratic equation. There's a k squared. There's also a k. But there's a 3 on the right side. So we can't factor it yet because 2 numbers or 2 factors that would be multiplied together, if we want to know when that equals 3, there's so many possibilities. We have to take both of them into account at the same time. We don't want 3 over there. We want 0 over there. So we only have to look at one factor at a time instead of both. So first step, move the 3 over so that this is 42 equals 0. And now we can factor it. We do a times c, we get 42. Factors of 42 that add up to -13. And that would be -7 and -6. K minus 7, K minus 6 equals 0. 2 solutions. From this one, you get K equals 7. From this one, you get K equals 6. By setting those equal to 0 and solving. I will make another video that goes through factoring when the leading coefficient isn't 1. And then we'll do some factoring of some higher degree functions.